Welcome to Twin Bush. I'm Bernd Stegmiller. There's a new tips and tricks episode today, especially about the electrical connections of a lift. We work with a 400 volt 3-phase power unit on our PE and heavy line models. We already have a connection cable on the control box. A plug-and-play commissioning is possible in theory. However, an electrician should connect the electric motor to the control box. We'll show you the right connection today, and what would happen if the connection was wrong. If everything is connected correctly, meaning phase 1, phase 2, phase 3, neutral wire, and protective earth, the lift can be turned on as usual. The green light is on. The electric motor is activated by lifting up. You can see the oil level sinks in the tank. That means the turning direction is correct now. I'll now simulate when the phase sequence is wrong. I will shortly alter something for this. I have now prepared an error in the control box which should show you what could happen during a lift's installation if the cable is connected incorrectly or when something is wrong with the supply. In this case, you can hear the motor running when lifting. However, the oil level doesn't sink this time. We can see movement in the tank. This is a sign that the motor is running in the wrong direction. After releasing the button, you can still hear the motor running. That means no hydraulic pull is generated. The lift doesn't go up. In such a case, it is 99% certain that a phase is twisted in the supply line, in the extension cable, in the control box in the workshop, or somewhere else in the supply. We'll now show you how to rotate a phase, how an electrician would test that all phases are present, and that they're in the correct phase sequence. Obviously, disconnect the supply before carrying out any work in the circuits. Our connection cable with a 16 amperes CE plug, which is pre-mounted, is routed into the control box at the bottom from the factory. It's connected to the terminal block here. Blue neutral, brown would be phase L1, black would be phase L2, gray would be phase L3. Yellow-green is clearly the protective earth, which is connected to the collective earth in contact on the top hat rail. In any case, when the phase sequence in the plug in the workshop or in the extension cable is unfitting, please let it be fixed by an expert, or if needed, simply switch the phases directly here. In this case, the order is wrong now. We have simulated an error in the supply. We'll now switch phase L1 with L2. This means brown and black. We take L1 out. We take L2 out. Both are interchanged. Make sure the wire end ferrules are completely turned in. We've now rotated the phase in the supply. After plugging in, our electric motor should turn in the right direction. That means the oil level sinks. Main switch on. Oil level sinks. I will simulate one more error for you now, when a phase is completely missing in the supply. This often creates a lot of confusion. If a three-phase electric motor is operated with only two phases, sooner or later it will overheat, overload, and it will burn.
Überlastet wird Ihnen durchbrennen. Auf den ersten Blick
At first glance, it doesn't seem like an error, because the motor is only running with a light load. I'll also simulate this shortly. I have disconnected a phase in the supply.
abgeklemmt. Das heißt,
This means the control box is still supplied with voltage but only in two phases. However, the electric motor needs three phases to run in the right direction
läuft.
and to run with power. If it's operated with two phases, the motor will randomly run in any direction.
Willkürlich. Entweder geht die
The lift will either go up or stay put.
in diesem Fall
In this case, the motor ran in the right direction. The oil level sank. The more I push. Now it doesn't run at all. It lacks power. I can push again.
jetzt läuft er an.
Now it runs. It runs in the wrong direction.
Nach erneutem Drücken
After pushing again,
kann es sein,
it could run in the right direction. Those are typical phase problems. When a phase is missing in the supply, for example, I'll shortly show you how to prove the right phase sequence and that all phases are present with the help of a multimeter. To check that everything is perfect with the phases of the input voltage side, take a normal multimeter. Look for the largest possible measuring range for AC voltage, V in the wavy line,
V die Wellenlinie. Schwarz in Com,
black into com,
Rot bei Volt.
red into volt.
Mit dem
Black goes to the earthing,
auf den Schutzleiter. Mit dem Rot
red goes to phase L1. 237 volts is okay. A voltage between 220 and 240 volts can be expected here. Phase L2 then. It should be an identical result. 236 volts. Phase L3. Also 237 volts. Phase to phase should measure between 380 and 415 volts.
80 und 415 Volt.
It's okay. Phase to phase. Next one.
Nächste
413 volts. And phase to phase.
Gegenphase. Also jeweils
So, measure each phase against the protective earth, around 230 volts. Phase against phase, around 400 volts.
Volt.
If a phase is missing in the supply, the following phenomenon will arise. The motor will either turn right or left, or it won't run at all. And it can't run because it's powerless.